Today we're going to look at one additional example of the sampling distribution for the sample proportion, or what is also called p-hat. So here I have an example looking at the proportion of heffalumps with the gene for flappy ears. Now we know from the population that all heffalumps have 60% who carry the gene for flappy ears. So suppose that we are going to take every conceivable random sample of size 100 from this population. So we have to give the appropriate information for that particular sampling distribution. Now, if you remember, there are three pieces of information necessary for a sampling distribution. That's the mean, the standard deviation, and the shape. Now, by definition, the mean of the sampling distribution of p-hat is p. As a reminder, p represents the population proportion. So here, because we are told that the proportion of all heffalumps with the gene for flappy ears is 60%, p equals 60% or 0.6. That also means then that the mean of the sampling distribution of p-hat for this scenario is 0.6 or 60%. Now for the standard deviation, we have the formula p times 1 minus p divided by n, and then we take the square root of that whole quotient. So here we're told that p is 0.6 as previously stated, and n is the sample size. We're told that n is equal to 100, so that helps us to calculate the standard deviation of this sampling distribution. Now finally, by definition, we know that the sampling distribution of p-hat will have the normal curve if n times p and n times 1 minus p are both greater than 10, greater than or equal to 10. So here we expect that the sampling distribution of p-hat will be normal because both of those criteria are met. So when asked information about the sampling distribution, those are the three pieces of information that are necessary: the mean, the standard deviation, and the shape.